Have you ever looked up at the night sky and felt a sense of profound connection? A feeling of being part of something immeasurably vast and ancient? We see the moon, a familiar companion. We see the stars, distant suns scattered across the darkness. And sometimes we see the planets, our neighbors, wandering across the celestial stage. Now imagine a moment, a truly spectacular cosmic performance, where all these wandering worlds decide to line up. Mercury, Venus, Earth, Mars, Jupiter, Saturn, Uranus, and Neptune, all standing in a row, like cosmic dancers waiting for the music to begin. What would happen then? Would the world end in a cataclysmic finale, as some have feared? Or would it be just another day in the life of our solar system, a fleeting and beautiful moment of order in an otherwise chaotic universe? The idea of a grand planetary alignment has captured the human imagination for millennia. It speaks to our innate desire for order, for seeing patterns in the grand tapestry of the cosmos, as if the universe itself is arranging its most precious jewels on a single thread of light, just for a moment. This vision sparks a deep and primal curiosity within us. When we talk about a planetary alignment, the image that often springs to mind is one of perfect geometric precision. We imagine looking out from the sun and seeing all 8 planets forming a perfectly straight line. However, the reality of our solar system is a little bit more complex and a lot less tidy. The planets do not all orbit the sun on the exact same flat plane. Think of it less like a set of grooves on a vinyl record and more like a collection of hula hoops, all spinning around a central point, but each tilted at a slightly different angle. This three-dimensional nature of our solar system makes a truly perfect single-file line of planets an event of almost impossible rarity. So what do astronomers actually mean when they discuss an alignment? Typically, it refers to a situation where the planets are all gathered within a relatively small sector of the sky. Imagine you are standing in the middle of a large circular room and all your friends are walking around the edge. An alignment would be when all of them happen to be gathered along one short section of the wall. This is what we see from Earth, a beautiful string of pearls, where several planets appear close together in our night sky, often near the horizon just after sunset or before sunrise. While not a perfect straight line from a physics perspective, it is a magnificent spectacle for anyone with a pair of binoculars or a small telescope. Just how rare is such an event? Let's consider the grandest version first, that impossible perfect straight line including all 8 planets. The orbital periods of the planets vary enormously. Mercury, the innermost planet, zips around the sun in just 88 Earth days. In contrast, distant Neptune takes a leisurely 165 years to complete a single orbit. For all of them to line up perfectly, they would all have to arrive at the exact right spot in their respective orbits at the exact same moment. The mathematics of this is staggering. The odds are so infinitesimally small that for all practical purposes, it is an event that will never happen over the entire lifespan of our solar system. Now let's consider the more realistic definition. All the planets gathering in the same small sector of the sky. Even this is an exceptionally rare occurrence. Think of it like trying to get 8 people, all walking at different speeds around a giant circular track, to all be on the same short straightaway at the same time. Calculations suggest that the 8 planets of our solar system group together within a relatively small arc of the sky only once every several centuries. The last time something like this happened was over 1,000 years ago. In June of 2022, for instance, a beautiful alignment of 5 planets, Mercury, Venus, Mars, Jupiter, and Saturn, was visible to the naked eye, a stunning sight for stargazers around the world. The reason planets align is down to one simple yet profound concept: gravity. It was Isaac Newton who first laid down the universal law of gravitation. The Sun, being by far the most massive object in our solar system, containing more than 99.8% of all the mass, exerts the most powerful gravitational pull. This is what holds the planets in their orbits. Imagine swinging a ball on a string around your head. Your hand is the sun, the string is the force of gravity, and the ball is a planet. Each planet travels on its own path, its own ellipse around the sun, dictated by the speed at which it was moving when the solar system first formed. The planets closer to the sun, like Mercury and Venus, feel a much stronger gravitational pull, and must travel much faster to maintain their orbits. That's why their years are so short. The planets farther out, like Uranus and Neptune, feel a weaker pull and move more slowly through space, resulting in their incredibly long orbital periods. This intricate system, governed by the precise laws of gravity and motion, operates like a magnificent, self-winding clock. There are no mysterious forces at play, only the elegant and predictable mathematics of physics. An alignment, therefore, is not a special event that the universe plans. It is simply a consequence of this clockwork motion. It's a matter of timing. Whenever the planets gather in the sky, a familiar chorus of myths and doomsday predictions seems to follow. For centuries, people have linked these celestial events to terrestrial disasters. Earthquakes, volcanic eruptions, massive floods, and even the end of the world itself have all been blamed in advance on an upcoming planetary alignment. The most famous modern example of this was the Jupiter effect, a theory popularized in a 1974 book. The authors predicted that a planetary alignment in 1982 would cause a chain reaction of solar flares, leading to catastrophic earthquakes on Earth, particularly along the San Andreas Fault in California. The prediction caused widespread public anxiety. People prepared for the worst. But when the date of the alignment came and went, nothing happened. The sun remained calm, the Earth's tectonic plates did not shift any more than usual, and California remained intact. The Jupiter effect was a complete and utter failure, a powerful lesson in the difference between speculation and rigorous scientific calculation. So why are these myths so persistent? They tap into a deep-seated human instinct to find meaning and connection between the heavens and our own lives. It feels intuitive that such a grand cosmic event must have an equally grand effect. These narratives are compelling stories, but they crumble under the scrutiny of basic physics. The fear they generate is based on a fundamental misunderstanding of scale and force in our solar system. Right, to understand why alignments have, well, no catastrophic effect, we need to talk about the numbers. Gravity is a force that weakens dramatically with distance. You feel the Earth's gravity strongly because, you're right next to it. But the gravitational pull of a distant planet, even a giant one like Jupiter, is incredibly feeble by the time it reaches us. Let's put it into perspective. The dominant gravitational force on Earth, by an overwhelming margin, is from the Sun. It's what keeps us in orbit. The second most powerful gravitational influence is the Moon, which is very close to us and honestly is the primary driver of our ocean tides. Now consider the planets. Jupiter is the largest planet in our solar system, more than 300 times the mass of Earth. But it is also at its closest, about 600 million kilometers away. At that distance, its gravitational pull on you is thousands of times weaker than the pull of the Moon. And what about the other planets? The combined gravitational pull of all the other planets in the solar system, even if they were perfectly aligned on the same side of the Sun, is negligible. It's a whisper in a hurricane. The change is far, far less than the normal variation in the Sun's gravitational pull that Earth experiences simply by moving from its closest point to its farthest point in its own slightly elliptical orbit each year. If the planets have such a tiny gravitational effect, what about the tides? We know that the Moon's gravity pulls on Earth's oceans, creating the familiar rhythm of high and low tides. The Sun also has a tidal effect, about half as strong as the Moon's. When the Sun and Moon are aligned with Earth during a new moon or a full moon, their gravitational forces combine to create higher than usual spring tides. Could a planetary alignment add to this effect and create monstrous megatides? Once again, the answer lies in the immense distances involved. The tidal force a celestial body exerts depends not just on its mass, but very strongly on its proximity. It's the difference in the gravitational pull on the near side of Earth versus the far side of Earth that creates the tidal bulge. Because the Moon is so close, this difference is significant. For a distant planet like Jupiter, however, the difference in its pull on opposite sides of our planet is almost immeasurably small. The tidal force of Jupiter on Earth's oceans is about 1 million times weaker than the Moon's. Even Venus, our closest neighbor, exerts a tidal force that is more than 10,000 times weaker than the Moon's. Let's imagine the most extreme and physically impossible scenario. All the planets are not only aligned with Earth, but are also at their absolute closest points to us in their orbits. Even in this fantastical situation, their combined tidal effect would be a tiny, insignificant fraction of the effect from our own moon. The change they would make to our tides would be less than a millimeter. Humanity's fascination with planetary alignments is not a modern phenomenon. It stretches back to the dawn of civilization. For ancient cultures, the sky was a divine canvas, and the planets were powerful actors. In Babylonian astrology, one of the oldest systems, the positions and groupings of planets were believed to hold sway over the fates of kings and empires. One notable historical event often linked to an alignment is the Star of Bethlehem. In the biblical story, a bright star guided the Magi to the birthplace of Jesus. While many explanations have been proposed, from a comet to a supernova, one compelling astronomical theory suggests it may have been a series of rare planetary conjunctions. The Grand Alignment of 1186, which saw all the known planets of the time gather in the constellation Libra, caused widespread panic across Europe. Astrologers predicted winds of apocalyptic force, earthquakes, and famine. People reportedly sealed their windows and hid in caves. Of course, the date passed without incident. Even in more recent history, alignments have captured our attention. The 1982 alignment that sparked the Jupiter effect scare was met with a mix of fear and excitement. While some prepared for disaster, observatories hosted public viewing parties, celebrating the chance to see the planets grouped together. This dual reaction highlights our evolving relationship with the cosmos. So what does this journey through the science and myth of planetary alignments teach us? It reveals a profound truth about our place in the universe. We live in a solar system governed not by caprice or divine mood, but by elegant, universal, and understandable laws of physics. The force of gravity, acting across immense distances, choreographs a silent, beautiful ballet. The planets move in their orbits with a predictability so precise that we can map their dance for millennia. An alignment is not a disruption of this order, it is a manifestation of it. It's a fleeting moment when the clockwork of the cosmos reveals a particularly beautiful pattern to us, the observers. This understanding does not diminish the wonder, it enhances it. Knowing that the alignment poses no threat allows us to appreciate it for what it truly is, a rare and beautiful spectacle. Seeing them gathered together in our sky is a family portrait, a reminder of the diverse and fascinating worlds that share our sun. Our enduring fascination with these cosmic events also tells us something important about ourselves. We are pattern-seeking creatures. We look for meaning, for connection, for signs that we are part of something larger than our everyday lives. Science provides a different kind of meaning, one based not on fear or superstition, but on the intellectual joy of understanding. The story of the universe, as revealed by science, is more magnificent and awe-inspiring than any myth. It's a story of immense scale, incredible age, and intricate beauty. Ultimately, looking up at the planets, whether they are aligned or scattered across the sky, is an act of perspective. It reminds us that our world is one of many, that our sun is one of billions, and that our lives are a brief but brilliant flash in the grand cosmic timescale. A planetary alignment is a gentle nudge from the universe, encouraging us to look up, to wonder, and to appreciate the magnificent, silent, and harmless reality of the cosmos in which we are so fortunate to exist. It's a show put on by gravity and light, and we have the best seats in the house.